Hey y'all, welcome back. Welcome back to the channel. Good to see you again. Hope you're all well. Today on my bench I got a Denon cassette deck. This is a DRM 740. It was brought to me by one of my loyal customers. Brings me a lot of other stuff to fix, and this was another one of his collection. Apparently this was given to him by his brother, I think, and he wants it checked over because I think he tried it and it didn't work. I'm not sure if he tried it or not, but let's try it right now. I got it connected to my realistic amplifier. Let's see. We have a tape installed. XTC's The Big Wheel. It's an album from the 80s, I think. Okay, so it installs and loads. Let's try playing. Get no audio. And then it shuts down. Let's try it again. The tape is moving, and it looks like it's going the correct speed. There's no audio, and then it shuts down. So something's definitely going wrong here. Okay, just a quick visual inspection here. Looks like we have, let me unplug this first before I poke my fingers in here. Okay, so just a quick visual inspection here. We have a power supply board. I already unplugged it. And it seems like under here is all our power supply regulation. Tape drive mechanism, everything looks good that I can see. The belts are all on. Everything seems to be okay. There's our three motors. There's one here, here, and here. And then we got a couple of boards for the audio processing, and I assume this board is more for the logic control, and this is more audio processing, but what do I know? Front panel board. So I'm looking here, I don't see anything really standing out other than, let me zoom in here a little bit, and I'll show you something that stands out a little bit. We've got those line of capacitors there in the power supply. They're all held down with hot snot. And it looks like, I don't know if you see those two capacitors on the left, looks like it's sprung a leak. I don't know if that's glue, circuit glue, or if that's actually electrolyte, but it looks like it's over that jumper and it's corroding that jumper. The tops of those two caps are a little puffed up as well. They're a little swollen. So maybe it's just a bad capacitors we got going on here. Alright, so now I got the power supply out. I can plug it in, I can switch it on, and we can test the outputs here on these. There's three regulators here, 7908, 7808, so we got a plus minus 8 volt supply for probably the audio circuits. And there is a 7906 here. I don't know why they put a 6 volt regulator in. Okay, let's check the outputs on these three regulators. I'll just turn it on and get my ground connection here. Okay, so let's do the positive ones first. This is the input, 16.5 volts. Output of the 6 volt regulator, 6.1, it's good. Input to the 8 volt regulator is 16.5 again, thanks. And the output, 8.1. And this is the negative 8 volts. The input is minus 16.5. This should be the ground. Yes, and the output is 8 volts negative. So they're all good. I'm still looking at these capacitors. They check fine on my ESR meter, but I still see these puffy tops on them. I'm going to remove them and check them out of circuit because I suspect those caps are. Alright, so I removed those 4 caps and tested them, and that turned out to be a nothing burger. They're all good. You can see here, this is circuit glue in between these two heat sinks and a little bit of corrosion. I'm going to clean all this out. I have to remove these heat sinks first and clean all that out. But looks like everything's good so far in the power supply. I'm just going to clean this up. Somebody added hot snot to those capacitors after. You can see it here on some of the other spots. There's hot snot. So I got the power supply all reassembled and put back together. I'm just going to anchor these heat sinks and caps with some silicone. It's going to work a little better than the hot snot that was put on there before, because the silicone is a little more immune to the heat than the hot snot. Let's test it one more time. I don't expect it to have fixed what the problem was, but at least we confirmed the power supply wasn't the issue. The reason I went after the power supply first is because this exhibited two different faults, if that makes any sense. One fault was that when I put it into play mode, it would play for 5 seconds and then shut down, which tells me that something's not right with the end of tape sensor, maybe. And the other fault was that we had no audio. So I don't know if those two are related or if they're two separate faults. If they're two separate faults, that might have been a power supply issue. That's why I went after the power supply first. I just wanted to make sure that we were confirmed that everything's good there, so we know it's working. So let's try it out one more time, turn it on, and everything looks normal again. Let's see, let's try play. We still have no audio, and it still shuts down. So we still got a problem, and let's have another look here. Let's try this again. Okay, so what I just did there is I touched this pulley. Let's zoom in here, I'll show you. This belt is slipping, and the cassette mechanism didn't fully load into the play position. So let's try that again. Let's try that. And this motor is still spinning because it's not loading. If I touch it and help it, so okay, I think that's our problem, is that one belt is slipping. Now, sounds like it's playing slow as well, but we'll get to that after. Let's address this belt. Okay, I just want to show you this belt that's slipping. It's right there, that motor. And if I help it along a bit, it starts. So to get that belt out, I'm going to need to remove this plate, because if you can see that pulley it's got a bearing on both sides, and there's no way to slip that belt over that shaft without removing this plate. So I think the whole mechanism will need to come out, and I think what I'm going to do is I'm just going to remove the front panel, and I think the cassette mechanism will come off with the front panel. That's my hope here. So I'm just going to do that right now. To remove the front, you remove the 3 screws from the top, and this fascia comes off. Don't believe there was no screws in the bottom. It just snaps onto the bottom and screws on the top. You remove that. Then there was 4 screws on both sides, 1 and 2 on each side. Remove those, remove all the connectors, and the bottom is just snapped in with these hooks. There's a hook on the side, a hook on each side, and then there's a hook on the bottom here, and then the front panel just comes right off. So once you remove the front panel, it's easy enough to remove the drive mechanism from the front panel. Just 4 screws, and it comes right out, and makes for easy cleaning of the capstans, rollers, and the head. It's got a 3-head setup, so you'll need to demagnetize these because it's got a record and playback head, and they're separate. Another thing I want to point out to you is this, the 2 capstans. Have a look at this one. Diameter of this shaft, and it's about 2.46 millimeters. And this one here, 2.15 millimeters. There's a difference between these two, and that kind of explains because the 2 flywheels have different diameters themselves, so they won't be spinning at the same speed. I was wondering, I was looking at this earlier, I says, why would they have different flywheels, diameter flywheels? You know, that's only going to cause them not to spin at the same RPM. But they compensate it for it here on these shafts. So I don't understand the reasoning behind that. It could have been just as easy to make them both the same diameter and use the same part. But I guess in their wisdom they didn't. So this is all cleaned, and I'm probably going to maybe clean these rollers a little bit more. They were kind of dusty, like it sat for a lot of years without being used. So I'll give it a better clean and then reassemble, and then we'll have to do a speed adjustment because I do believe it is running slow. So I noticed when I was doing my initial testing that this pot here, this is the output level pot, is quite scratchy, and I have a feeling these other two might be scratchy as well. And I'll do the other the input level pot. But these pots are not very cleaning friendly, and I don't think I see any openings. I'm gonna have to remove them from the board. I could probably remove it. You know what, I'm just gonna take this board out, and then I'll remove these 3 pots and clean them, and that way I know it's done. And because I don't think spraying in here from any angle is gonna get the cleaner into where I need it to be. So I removed the pot, and I'm having a look at it here, and there's no way to spray anything into this thing. If you have a look at it, there's no openings to the outside world other than letting it dribble in from the shaft, and kind of with blind luck maybe it's going to reach it, the spot it needs to be. So what I'm going to do is I'm going to drill a hole in the top of this, and I'm going to put in a little bit of this stuff. So what I've done is I measured this spout thing, and it's 50 thousandths. So I'm going to pick out a bit here. It's a 50 thousand. All I got is a 52 thou, so we'll use that one instead. That's my closest one. I'll put this in here. So all I want to do is very carefully drill a hole through the top of this. I don't want to penetrate with the bit to destroy any innards. I just want to make a hole. I think that's the best spot. I probably should have done it right in the center, but I'm trying to go easy because I don't want to break through and push junk inside. So take a little bit at a time, clean the hole until I penetrate enough that I can get a little squirt in there. Okay, so this bit is 40 thousandths and a little smaller. And all I need to do is puncture a little hole in the plastic. Keep going easy. You don't want to put any force to break through. Still not through yet. Doesn't even seem to be cutting. Maybe my bit's dull, but it should go through plastic. I don't want to put too much force on it. Okay, I think I just broke through there. I'm going to pull it out. It pretty much drilled right down to the shaft. Clean this out. Pretty sure I broke through. I felt it grab. So I'm just going to give it a little shot of this. And it gets a piece of tape and cover that hole up, and then we're done. Okay, so we're all back together. Everything seems to be working. I'm just going to do a test on the playback. Pots aren't scratchy anymore. So it loads up, sounds good, it's playing quiet, it's not making any funny noises. I think we got it all. Now we need to do one last step, is set the playback speed, because I don't think it is playing the correct speed. Let's try some of these features out. Music search, see if it picks up the next song. Four minutes, 5 minutes. I think it missed the next song. I'm not exactly sure how that works. Okay, so let's get a tape, my speed tape loaded, and then we'll get set up for the speed test. Okay, I'm having troubles here setting the speed up. I couldn't get my frequency counter to lock on the Opus signal. There's too much hash and noise in it from tape hiss and whatever. It just doesn't want to cooperate. So what I'm doing is I'm going to put my scope in XY mode, and I'm feeding it a 3 kilohertz signal from my signal generator, so that signal's rock stable. And what you're seeing there on the screen is the horizontal axis. That's the 3 kilohertz. If I shut the signal off, it goes to nothing, and then you can see the noise that's coming from the tape deck itself. It's a spurious noise from my bench, and it's EFI. Let's get the tape rolling here, and what I want to do is I want to adjust it for, turn the noise down, and let's turn this pattern down a little bit. Okay, close enough. So what we want is we want to create either a straight line, diagonal straight line, or a circle. Getting closer. Okay, that's too low. This is really finicky adjustment, and I really don't have the right screwdriver for going in behind this motor here. I think this pot is really tough to turn. And plus it's flaky. Okay, let's doesn't seem like I can get a lock on this. right about here, but it just doesn't. No, this isn't working. It's close. There we go. It's very, very close. Now the wow and flutter on the tape deck is going to create that jumpy noise. I think it's pretty much as close as I'll get it. It might be a few hertz out. No, see, now I'm out quite a bit more. Let's put it back to where it was. That's about as stable as it's going to get with my hand adjustment. So that should be pretty close to 3000 hertz right there. Now, like I said, the wow and flutter on this machine is really making that pattern jump around. My signal generator is stable, but the tape deck is not. It's pretty close. It's within, I would say, a few percent, or less than 1%. All right, so here it is. It's the motor. I took it out. I wasn't happy with the speed regulation of this motor. It was all over the place. Speed was jumping all over. It had flutter, and I think maybe a cleaning and maybe lubrication of this motor is in order. So let's open it up, and actually here, let me grab my vise. It's easier to work on stuff with when I can hold it. There we go. Okay. Yeah, so I just wasn't happy with the what I was seeing and the sound I was getting. Okay. Now we need to pop this cover. A little bit of tape here on this side. Let's remove that. So there's our date code, November 16th of 93, and that coincidentally is the birthday of my son. Okay, so let's pop the lid on this if we can. It's probably pressed in, and let's see if we can get this thing out. There we go. Okay. And the potentiometer is way deep in there. So what I'm going to do is I'm going to desolder these two motor connectors on the motor, and this PC board should just lift out. So let's try this. Let's try lifting on this. Try lifting on this. There we go. There's our electronics board. I'm going to give that trim pot a little cleaning with some deoxit, but we still need to get into the motor itself to clean and lubricate the bearing. The bearing's hidden behind here, so I should be able to lift this white plastic cup out, and I think all it is it's holding. I don't think it's secured any other way. Yeah, see? So it should lift right out. Just want to take a peek in here at the brushes before I go too far. Okay. There's two slots here for holding the brushes back from the commutator. And there's probably a special tool that you use to put this back together. Let me see if I can pull this pulley off. It looks like it's glued on. And yeah, I don't have a puller for that. I should actually make one or get one made. Something that will pull that out. Okay, give me a second here. Alright, so I was able to pull off the pulley and it wasn't on there that tight. I just gave it a tug and it came off. It seems like they have it secured on there with some kind of a adhesive. You can see it from here. And then there is a plastic washer on there that is just a grease. It keeps the oil from oil slinging. So we got to push this out, and what I got here is a T7 Torx bit, and it's just big enough to push this out. You don't want to pull this off because you'll damage the brushes, but you want to push it out as a unit, just so that it clears the magnets, and then you can take out this. But most importantly, we can get to that bottom, or that bottom bearing. So the commutator is kind of dirty. I was looking at this under a magnifying glass. It is kind of dirty, but I don't think that's the cause of our wow and flutter. I think just a general lubrication is going to bring this one back. So I'm going to clean this anyway. It looks like it's silver plated as opposed to copper. See, it wasn't very dirty. A little bit of dirt off of there. But I think what's going to give us the biggest bang for our buck is when we lubricate this and put it back together. So I'll do that now. Let me see here. I need a cloth. And get some lubricant to that bottom bearing there. Just want a little bit, don't want much. I know people take these bushings out and then they re-lubricate them with in a vacuum process. You suck out all the air and then you impregnate it with oil, and the oil gets sucked back into it when you let the air pressure get back to it. I'm just going to give it some this. There, I think we got enough. Now we need to reassemble this. So I need to get the brushes out of the way and do that from behind here, if I can get this to cooperate. Alright, I did manage to get it in. And we got to give it a good inspection, make sure those brushes are in the right spots, and they are, so that's good. Now this is the tricky part, getting this back into the thing, because the magnet's going to want to suck the armature. So we insert a screwdriver here. Yeah, let's get this positioned properly first. This cutout goes here. Let's get this. I don't think it worked. Well, maybe it did work. Okay, so that's back together. I can now reassemble the printed circuit board. I'll give it some deoxit. So I'm going to lubricate this bushing here. That's turning actually pretty nice. Silent too. Maybe that was all it needed. Okay, I'll finish pre-assembling this and then I'll get it back in the machine. We'll see how it sounds. Okay, so this is after the motor has been reassembled and lubricated. It's just a little bit better, but it's still drifting. I'll set it up and I get a good pattern, then it slowly drifts away. So it's got some drift in the motor as it heats up. What I might do is let this tape play through, rewind it, and try it again. See, now it's getting to the point where you can't even recognize it. What I've done is I took the motor, when I reinstalled the motor, I turned it so that the adjustment hole was flipped up. So I can get a screwdriver in here a lot better now. And see if I can tweak this a little bit more. It's right about there. It's really hard to zero in on the pattern because you're asking the tape drive to synchronize with a 3000 hertz signal, and it's really tough, especially when you've got a tape mechanism that's got all this wow and flutter. But it seems to be a little better. Oh, there we go. Maybe I didn't have it on the right harmonic. There we go. Ideally what I want to get is a diagonal line, but that'll never happen because it's too busy jumping around. And I'll settle for a circle. Right there should be good. I'll let that go. Alright, so we'll get this back to the customer. I think I'm done with it now. I got the motor back in. I think it's a little better. The speed's a little more stable now that I lubricated it and cleaned it. It's still, it's a cassette deck. What do you expect from a cassette deck? So it's all mechanical drive, so there's going to be variations in that. So let's just have a little listen to how it sounds. Some royalty-free music here. No? Pots are clean. I'm not going to do a test record. I'll do a test record after I finish with the video and then send this back to the customer. But for now, I think we're done. Sounds pretty good to me. Anyways, that's it. Thanks for watching.